This video is on section 2.1 notes, U.S. customary units and unit conversion. And for this set of notes, you're going to need this sheet printed out because we're going to refer to it. So this is your conversion table. All right, so to do these unit conversions in U.S. customary, and even when we get to the metric system as well, we're going to use the unity fraction method. And so the way this method works is we do a four-step process. First, we write an equation that relates the two units that are going to be converted. So maybe it would be inches and feet, or pounds and ounces, or quarts and gallons, or yards and feet, or feet and inches, cups and quarts, etc. And then we're going to create two ratios from the equation, and each ratio is going to have a value of 1 because you're comparing two equivalent things. They'll be in different units, but they'll have a ratio of 1 because they're equivalent. Next, we'll use the ratio, which will allow the unit that we want converted to cancel and the unit that we want measured to be introduced. And then last, we'll multiply our fractions, which means that we're going to be multiplying the numbers in the numerators and we're going to be dividing by the numbers in the denominators. So to start, we're just going to write some unity fractions, so these ratios that have a value of 1. We're going to write unity fractions for these measurement equations. So for example, 12 inches and 1 foot, those measurements are equivalent, they're the same. So 12 inches over 1 foot, this is a ratio of 1 because those lengths are the same. 1 foot over 12 inches, that's also a ratio of 1 because those lengths are the same even though they have different units. These weights, 1 pound over 16 ounces, 16 ounces over 1 pound. Here we have weights again, or volume, 4 quarts over 1 gallon, 1 gallon over 4 quarts. And then measurements of time, 60 seconds over 1 minute, 1 minute over 60 seconds. So whenever you have two measurements that are equal, you can always write a unity fraction, that's what these are called, with either of the measurements in the numerator or denominator of the fraction. All right, so next we're going to use those 4 steps to do unit conversions. So we want to convert 4 yards into whatever the number of feet that would be. So I'm going to start by writing 4 yards times, and I want to come up with the unity fraction that would allow me to get rid of the unit's yards and introduce the unit's feet. So I want a unity fraction. I want to compare yards and feet. And so I'm going to look on my conversions. I can see right here that we have the conversion that compares yards and feet right here. So 1 yard and 3 feet are equivalent. And then over here, I have to think about, should I have 1 yard in the numerator and 3 feet in the denominator? Or should I have 3 feet in the numerator and 1 yard in the denominator? I have 2 different ways I can write it, always 2 different ways. So I want to cancel out the yards. So I want yards in the denominator of the unity fraction so that these units can cancel. And I want to introduce the unit feet. So I want the unit feet to be in the numerator. And then I'm going to go ahead and write the numbers that go with these units. So 3 feet and 1 yard. And then when I look at multiplying these numbers, whatever numbers are in the numerator are going to multiply, and whatever numbers are in the denominators will end up dividing. So 4 times 3 is 12. And so 4 yards is equivalent to 12 feet. All right, let's try this again with ounces to pounds. So 44 ounces. I'm going to multiply this by a unity fraction. My unity fraction is going to compare ounces and pounds. So I have to look over here. compare ounces and pounds. 1 pound and 16 ounces are equivalent. So I can either have 1 pound on the top and 16 ounces on the bottom, or I can have 16 ounces on the top and 1 pound on the bottom. I know that I want the ounces to cancel, and I want to introduce the pounds. So ounces on the bottom so that they will cancel, pounds on the top so that that unit will be introduced. And it was 1 pound to 16 ounces. So anything that's on the top will multiply, anything that's on the bottom will divide. And so 44 times 1, that's not going to change the number at all. So I'm just going to go ahead and do 44 divided by 16. 2.75 pounds. Okay, 6.25 feet to inches. So I've got space for my unity fraction here. I'm going to compare feet with inches. So 1 foot is 12 inches. And so I want to cancel out the feet and I want to introduce the inches. 1 foot is 12 inches. So I know 1 foot is 12 inches. The 12 is on the top, so I'm going to multiply those numbers together. 6.25 times 12. 75 inches. Cups to quarts. 24 cups times my unity fraction. All right, and then we got cups. Now, this is an interesting one because we have cups compared to ounces and cups compared to pints and ounces, and pints compared to quarts, but we don't have a comparison that takes us from cups directly to quarts. And so that means we're going to have to draw 2 unity fractions. So I need 2 of these. And I have to get from cups to quarts. So I could go from cups to ounces to quarts, or I could go from cups to pints to quarts. So I think I'm going to go from cups to pints first. So let's convert it to pints. So first I'm going to say that 2 cups is 1 pint. I want to get rid of the unit of cups and introduce the unit pint. So get rid of the unit cups, introduce the unit pint. And we know that 2 cups is equivalent to 1 pint. And then next I want to get from pints to quarts. So from pints to quarts, 2 pints is equivalent to 1 quart. So from pints to quarts, I want to get rid of pints, so I'm going to put pints on the bottom. I want to introduce quarts, so I'm going to put quarts on the top. I know that 2 pints is equivalent to 1 quart. So 2 pints is equivalent to 1 quart. So when I do this multiplication and division, the cups are going to cancel with the cups, the pints are going to cancel with the pints, and I'm going to end up with quarts at the end. I know that any number that's in the numerator gets multiplied, so 24 times 1 times 1, and I'm going to divide by any number that's in the denominator. So I'm going to divide by 2 and then divide by 2 again. So 24 divided by 2, and then divide by 2 again, and I get 6 quarts. All right, 12 gallons, 2 pints. 12 gallons, 2 pints. So I did the same thing again for this one. We have gallons to quarts or gallons to fluid ounces, but we don't have gallons directly into pints. So from pints we have quarts, from pints we have fluid ounces, but we don't have pints directly to gallons. So again, I'll go ahead and from gallons to pints, I'll go from gallons to quarts, and then I can go from quarts to pints. So I'm going to take it in 2 steps. I'm going to use 2 unity fractions here. I know my final goal is pints, but I can't get there directly, so I'm going to go ahead and use quarts first. And you could use fluid ounces if you want. It's not wrong to do that. I'm just using quarts, honestly, because it's a smaller number than fluid ounces. So 1 gallon is 4 quarts. So I'm going to go from gallons to quarts. I want to cancel out the gallons, so I'm going to put this on bottom. I want to introduce the quarts, so I'm going to put quarts on top. And then I know that 1 gallon is 4 quarts. 1 gallon is 4 quarts. And then for the next one, I want to get from quarts to pints. So quarts and pints, 1 quart to 2 pints. I want to get rid of the quarts, and I want to introduce the pints. So quarts on the bottom to get rid of it, introduce the pints. And it was 1 quart for 2 pints. 1 quart, 2 pints. Okay, so when I do this, the gallon will cancel with the gallons, the quarts will cancel with the quarts, and I'm going to end up with pints. I'm going to have 12 multiplied by 4 multiplied by 2. It would be divided by 1, but that's not going to change a number if I divide it by 1. So 12 times 4 times 2 is 96 pints. All right, the next one says miles to yards. So 2.1 miles. And then I need to convert it into yards. Miles to yards, we have one that will go directly there. So 1 mile is 1,760 yards. So I want to get rid of the miles, I want to cancel out the miles, and I want to introduce the yards. So miles on the bottom to cancel, yards on the top to introduce it. 1 mile, 1,760 yards. So the miles cancel, and then I'll go ahead and multiply. $3,696 yards. All right, so this one says 11 pounds, 14 ounces to just ounces. So I'm going to circle this. I'm going to hold on to the ounces. I'm going to ignore those for a second because those are already ounces. I'm only going to deal with the pounds. So 11 pounds, and I'm going to convert it into ounces. I know that 1 pound is 16 ounces. 1 pound is 16 ounces. So I'm going to cancel out pounds. I'm going to introduce ounces. 1 pound is 16 ounces. And I'm going to go ahead and multiply those. So my pounds are going to cancel. 11 times 16, 176. But I also had the 14 that I've been hanging on to. I didn't do anything with it yet, so I'm going to add 14. So that's 190 ounces total. Okay. This one says 87 inches and convert it into feet and inches. So a lot of people don't say, I'm 5.7 feet tall. They might say, I'm 5 feet 9 inches tall, or I'm 5 feet 3 inches tall, or something like that. So we're going to convert it in that regard. So I'm going to start with inches and then we'll go from there. Okay, so we're going to convert it to feet. 12 inches is 1 foot. So I want the inches to cancel. I want to introduce feet. 1 foot, 12 inches. Okay, so the inches are gonna cancel, and I'm gonna do 87 divided by 12. 7.25. This is 7.25 feet. So if I'm writing this in terms of feet, I'm okay with the 7 feet, but I'm not okay with the 0.25 feet. I want the 0.25 to stay in inches. So I'm going to ignore the whole number 7. I'm going to take the 0.25 and I'm going to convert that back into inches. So 0.25 feet, convert that back into inches. So I want the feet to cancel and I want it back into inches. I'm going to cancel feet, introduce inches. So 1 foot, 12 inches. 0.25 times 12, 3 inches. So 87 inches, if we write that in terms of feet in inches, it would be 7 feet, 3 inches, or 7.25 feet. Okay. The next example says the average American consumes 44.7 gallons of soft drinks per year. How many 12-ounce cans would this be? So first, I'm just going to convert from gallons to ounces, and then we'll see how many cans of soft drinks that would be. So 44.7 gallons. I'm going to convert that into ounces, and I think that gallons converted, yeah, gallons can convert directly into ounces. So 1 gallon is 128 ounces. So I'm going to cancel out the gallons. I'm going to introduce the ounces. 1 gallon is 128 ounces. So the gallons will cancel. I had to divide instead of times. Let me fix that. So I'm multiplying because it's on the top. 5,721.6 ounces. Okay? And then to see how many 12-ounce cans this would be, I'm going to say 5,721.6 ounces. And our fraction, our unity fraction, is that we have 12 ounces per 1 can. Or 1 can per 12 ounces. So I want the ounces to cancel out, and I just want to have the number of cans remaining. So ounces and the number of cans. So each can, 1 can, has 12 ounces. So the ounces are going to cancel. This 12 is on the bottom, so I'm going to be dividing. Divide by 12. 476.8. So that's about 477 cans. So the average American consumes 477 cans of soda per year. So, I mean, yeah, that's a lot. More than 1 per day. All right, this example says the circumference of each tire on a truck is approximately 98 inches, which means that the truck travels 98 inches with each revolution of the tire. How many miles, not inches, how many miles will the truck travel if the wheels make 8,500 revolutions? and then it asks us to round to the appropriate number of significant digits, and we'll come back to that in a second. So if each truck tire is 98 inches in circumference, that means the perimeter around the tire is 98 inches, then that means every time you have one revolution, the truck is going to go 98 inches. So we need to do 98 times 8,500 to figure out how far the truck has gone in inches. So I'm going to multiply those first. 833,000. So we're going to take the 833,000 inches and we're going to be converting that into miles. So if I look here, I can see that my inches can convert to feet or into yards. But to get to miles, I either have to go from yards to miles or from feet to miles. So I have to do two unity fractions here. So I'm going to let the first one be converting from inches into feet, and I'll let the second one be from feet into miles. So first, I'm going to get rid of my inches. I'll make the inches cancel, and I'll introduce feet. So 1 foot per 12 inches. And then the inches have canceled. And then I'll have the feet cancel and I'll introduce miles. So feet up top, so feet will cancel and I'll introduce miles. 5,280 and 1 mile. And the feet will cancel and so we'll have miles. Okay. So 833,000, I'm going to have to divide by 12 and divide by 5,280. We have a lot of digits here in our answer. And the problem says to round to the appropriate number of significant digits. So we have two numbers in the problem. One is 98, which has 2 significant digits, and the other is 8,500 or 8,500, which is a 4-digit number, but it's a whole number that ends with zeros, and so the zeros are not considered to be significant. So I ignore the zeros, and this only has 2 significant digits. So I have a number with 2 significant digits and another number with 2 significant digits. And so that means that I should round my answer to have 2 significant digits. So I'm going to let my answer have these 2 significant digits, 13 miles. I know it's miles because that's the unit I have. And I'm going to ignore all the decimals, because they asked me to round to the appropriate number of significant digits. If they had given me 2 numbers and maybe one had 2 significant digits and the other one had 3 significant digits, I would just choose the one that had less. So I would choose 2 significant digits. All right, let's try the next few. So it says convert each of the following square and cubic measurements. So before we were looking at length measurements and weight measurements and liquid capacity. And now when we look at square measurements, we're going to be looking at areas. And when we look at cubed measurements, we're going to be looking at volumes. So it says 15.25 square feet into square inches. And again, the instructions here are telling us to keep in mind the significant digits as we round. And so for this problem, there are 4 significant digits. And so I'll keep that in mind when I write my final answer. So square feet to square inches, square feet and square inches. I want to get rid of the square feet. I want to introduce the square inches. So that was 144 and 1. And I said already that I want to have 4 significant digits, and this answer has 4 digits, and they're all significant, and so that's a good answer to write. Next, 4,800 acres to square miles. So acres to square miles, here, 640 acres and 1 square mile. So I'm going to get rid of the acres and introduce the square miles. 640 acres to 1 square mile. When I look at this number, it has 4 digits total, but only 2 of them are significant. The zeros on the end are not. So I'm going to keep that in mind. 7.5. So this is a number that has 2 digits, it's decimal, and both of these are significant. So 7.5 square miles. All right, cubic feet into cubic inches. And so we're using this again, oh, that was square, so we're not using that one. Cubic feet and cubic inches. We're using this one. Okay, so let me go ahead and write this down. We've got 0.250 cubic feet, and we're converting that into cubic inches. So cubic feet will be on the bottom. We're going to cancel that out. Cubic inches will be on the top. 1 cubic foot, 1,728 cubic inches. And here when we look at this, this is a decimal number, so the 0 in the front is not significant, but the 0 on the end is. So this is 3 significant digits. So 0.250 times 1,728, and I get 3 significant digits, so all of these are significant. All right, cubic inches into bushels. So cubic inches into bushels, BU is a bushel. So make sure you write that down if you haven't already. All right, so 10,500 cubic inches. Cubic inches are what we're canceling out. Bushels is the unit that we're introducing. 1 bushel, 2,150.42. So if I look at this number, it's a whole number that has some zeros on the end. The zeros on the end are not significant, so these two are not. The 0 in the middle is. So there are 3 significant digits in this number. Those two are not. Okay. And we're going to be dividing, not multiplying. And we want 3 significant digits. So I'm going to go ahead and write down a bunch of the numbers here. And if I'm including 3 significant digits, then I will have these 3. So 4.88 bushels. All right, next we're going to talk about compound units. And compound units are a unit of measurement that is created by combining 2 or more different basic units, such as miles per hour or cost per ounce. So, for example, a diameter in terms of inches is not a compound unit, it just has 1 unit of measurement. Gas usage is, it's miles per gallon. Rotation rate is a compound unit, is revolutions per minute. Density is a compound unit, it's pounds per cubic foot. The current, thinking of water or electricity, would not be a compound unit. You just say it's amps or amperes, I think is how you say that. Pressure is a compound unit, pounds per square inch. So what we're going to do next is we're going to take some of those compound units and we're going to be converting those. So we have a car that is driving 55 miles per hour is going at a rate of how many feet per second, and we're going to round according to significant digits. So 55 miles per hour would be 55 miles in 1 hour. And this is not how a lot of people think of this, but this is actually how those units work. If you're driving 55 miles per hour, it means you're doing that many miles in that amount of time, 1 hour specifically. And it's always that number per one of whatever that second unit is. So what we need to do is we need to get rid of the miles and introduce the feet, and we need to get rid of the hours and introduce the seconds. So I'm going to get rid of the miles and miles and feet. So 1 mile is 5,280 feet. So we got rid of the miles. Now at this point, our number would be in feet per hour. And then we need to get rid of the hours and introduce seconds. So if I want to get rid of hours and it's on the bottom, then I need to put it on the top so that it will cancel out. And then to introduce seconds, I'm going to put seconds on the bottom. So the hours will cancel. And hours and seconds, 1 hour, 3,600 seconds. 1 hour, 3,600 seconds. So when I'm done and I calculate this number, I will have feet per second as my units of measurement. So I'm going to multiply 55 times 5,280 divided by 3,600. And this is feet per second. And they told us to round according to the significant digits. So if I look in this problem, we had the one number to start with, 55. There's 2 significant digits there. And so I need to round to 2 significant digits here. And 80 is followed by a 0.6. And so this is going to be 81 feet per second. All right, the next one, convert 3.8 inches per second, 3.8 inches per 1 second. Convert that into feet per minute. So the first thing I'm going to do is convert the inches into feet. I need to get rid of inches, so I'm going to get the inches to cancel. I need to introduce feet, so I'm going to put feet on top. And I know that 12 inches goes with 1 foot. So now my number would be in terms of feet per second, and I need to convert it from seconds into minutes. So I want seconds to cancel, and so I'm going to put seconds on the top, so it will cancel. And then I want minutes to be introduced, and so I'm going to put minutes on the bottom. And I know that there is 60 seconds in 1 minute. And so that's the conversion I'll do there. And so the seconds will cancel, and that means my answer is going to be feet per minute. And they didn't tell me how to round here, so I'm just going to see what number I get. So 3.8 times 60 divided by 12. 19. All right, barley has a density of 38.4 pounds per cubic foot. 1 bushel of barley weighs 48 pounds. How many bushels of barley are contained in 3.25 cubic yards? So I'm just going to start by writing this out. These are units of measurement that I'm not very comfortable with. Well, first of all, barley I don't really deal with, but Cubic feet, something per cubic feet is kind of weird to me. Bushels, I'm not really used to talking about. And then cubic yards. And so when I approached this problem, I just started writing down what I knew, and I started working with my unity fractions, and the problem ended up not being as weird as it felt when I first read the problem. So barley has a density of 38.4 pounds per cubic foot. So we always do per 1 cubic foot. And it says 1 bushel of barley weighs 48 pounds. And so we have pounds here, and they said 1 bushel, and then they're asking us about bushels. So that means that we're doing something where we're converting from pounds into bushels. So I know that I want to cancel out my pound measurement, and I want to introduce a bushel measurement. And they're telling me the relationship right here. 1 bushel equals 48 pounds. So I'm not going to look at my table because they gave it to me in the problem. So I'm going to cancel out my pound measurement and introduce a bushel measurement. And it's 1 bushel is 48 pounds. All right, the other thing I want to do is I want to see bushels compared to cubic yards instead of cubic feet. So I've already put this into bushels instead of pounds. The pounds have canceled. I want cubic yards instead of cubic feet. So let me look at the relationship here. Cubic yards, cubic feet. So 1 cubic yard is 27 cubic feet. That's what I'm going to use. So cubic feet goes on top because I want these to cancel. Cubic yards is going to go on the bottom because I'm introducing that as a new unit to the problem. So 1 cubic yard to 27 cubic feet. And then this will cancel. And I'll end up with bushels per cubic yard, which matches what the problem is asking. How many bushels of barley are contained in 3.25 cubic yards? So those units match what they're saying. So now I can go ahead and calculate with the numbers. 38.4 times 27 divided by 48. So we have 21.6 bushels per cubic yard, or 21.6 bushels per 1 cubic yard. But if you read the question more carefully, they're not saying how many bushels of barley are contained in 1 cubic yard. They're saying how many bushels of barley are contained in 3.25 cubic yards. So this is 21.6 bushels per 1 cubic yard, and we want 3.25 cubic yards. So how many bushels contained in 3.25 cubic yards? So we're going to take the 21.6, we're going to multiply by 3.25, and we get 70.2 bushels were contained in 3.25 cubic yards. All right. In the next example, it says carpeting used to be sold strictly by the square yard, but now companies are pricing it by the square foot. Suppose Carpet City offered a certain carpet at $42.95 per square yard, and a competitor, Carpeterium, offered a comparable carpet at $4.95 per square foot. Which is the better buy? So we don't have to do math for both of them. We just have to do math for one of them to see which is the better buy. So we have $42.95 in dollars per 1 square yard, and we have $4.95 in dollars per 1 square foot. And so what we need to do is either convert this into square feet or convert this into square yards. It doesn't matter what we do, both of them would work equally. So I'm just going to take this one, $42.95 per 1 square yard, and I'm going to convert it into square feet. So if we look at this, 1 square foot, that's inches, 1 square yard is 9 square feet. So here's our conversion right here. This is what we're going to use. Okay, so I want to get rid of the square yards, and I want to convert it into square feet. And that way I'll have the amount of money per square foot, the amount of money per square foot, and they will have the same units of measure, and so we'll be able to compare the numbers. So square yards, square foot, 1 square yard is 9 square feet. So the square yards will cancel, and I just have to divide that number by 9. So, and I wrote that kind of weird. Oops, sorry. So it's 4.77 per square foot. And now if we compare, 477 per square foot is definitely less than 495 per square foot. And so that means that Carpet City is the better buy if they were selling the same carpets. All right. Last example, the 2017 Toyota Camry 4-cylinder hybrid has an EPA fuel economy rating of 40 miles per gallon. The comparable 4-cylinder non-hybrid has an average fuel economy of 27 miles per gallon, but it costs $3,720 less. If gas costs an average of $2.40 per gallon, how much money would the hybrid save over a 160,000 mile lifespan? So we have the hybrid, we have the non-hybrid, and we're going to calculate how much money these people who bought each different car are going to spend in gas over the lifespan of the car, and then calculate, well, the person who did not buy the hybrid saved money in the beginning, and see how much the hybrid owner saves because they paid less in gas, because their car had a better gas mileage throughout the lifetime of the car. So both of the cars had the same lifespan, 160,000 miles per one lifespan. So we're going to start off there for each car. And our goal is to get to the cost. How much money is this costing when we talk about how much gas we have to put in the car? So we know that for each of the cars, we have the miles per gallon that we get as far as gas goes. And so when I work my way towards talking about how much money it's costing, then it would be good for me to cancel out my units for mileage and introduce units for gallons, because then I can talk about how much money it costs per gallon. So if I get rid of the units for miles and introduce the units for gallons, then later I can get rid of gallons and introduce the dollar amount. So first I'm going to say, well, we have miles. I'm going to get rid of miles and introduce the number of gallons. So the hybrid was 40 miles for 1 gallon, 40 miles for 1 gallon. The non-hybrid was 27 miles for 1 gallon. And then we have the cost. This is where we are converting the amount of miles we drive into how much money we're paying for those miles. So the amount of money we're paying for those miles is $2.40 per gallon of gas. So $2.40 per 1 gallon of gas. So I knew that the $2.40 would go on the top because the 1 gallon had to go on the bottom to cancel out with this gallon right here. All right, so when I do all this multiplication out, I'm going to have the mileage cancel, I'm going to have the gallons cancel, and my units of measurement are going to be a dollar amount over the lifespan of the car. And so that's good because we're comparing how much the car is going to cost us over its lifespan. So miles cancel, gallons cancel, the dollar amount over the lifespan of the car. So 160,000 times $2.40 divided by 40 miles. So $9,600 over the lifespan of the car is how much they're expecting to pay in gas for the hybrid model. For the non-hybrid, model, you're expecting to pay $14,222 in gas. All right. Now, when you first bought the car, you automatically, for buying a non-hybrid car, you automatically saved some money. The gas mileage wasn't as good, but it cost a little bit less to buy a non-hybrid car. So this one was $3,720 less. So $10,502. So if you take in mind how much money you saved when you bought the car, then you could say that for the hybrid model, you spent $9,600 on gas over its lifetime, and the non-hybrid, you spent about $10,502 because you saved some in the beginning by buying the non-hybrid model. Now, the question that this problem is asking is how much money would you save if you bought hybrid rather than non-hybrid? How much money do you save overall by buying the hybrid model? And so what we're going to do now is just subtract these to see how much money you save. $902. You save $902 if you buy hybrid in the beginning.